Hi, this is Srikanth, Assistant Professor of EEE Department. In this session, I am going to discuss the advantages and applications of semiconductor devices. The major advantages of semiconductor devices. The semiconductor devices are basically classified into two types. One is diodes and transistors. So first, let us go with the advantages and applications of diodes. Then after we'll go with the transistors. So the advantages of semiconductor diodes. The first advantage is the rectification, that is the conversion of AC supply into DC supply is done with the diodes, and these are the major equipment which is used for the rectification process. Whenever we require a DC supply in order to charge the batteries like our mobile phones or laptop chargers, all these are going to have the rectifying operations inside our charger. So that rectification process we are going to use the diodes, and the size of the diode is very small and lightweight, because the size is very less, so which we can easily integrate into our electronic devices. And switching speed is very high. The many semiconductor devices such as Schottky diode have fast switching speeds, making them suitable for high frequency applications. The cost is low. The semiconductor diodes are generally cost effective to manufacture and making them economically viable for a wide range of applications. And long operational life. When used within their specified operating conditions, semiconductor diodes have long operational life. And applications of semiconductor diodes. In this, the major application is used in the power supplies. The diodes are fundamental components in power supply circuits in order to use for converting AC to DC for electronic devices. That is, during the rectification process, we are going to use the diodes, and that rectification process is going to be used in the power supplies like UPS, uninterrupted power supplies, where we are going to have the battery charging stations, and those battery chargings can be done with the rectification process. And light emitting diodes. Here semiconductor diodes that emit light are used in indicators, displays and lighting applications. And rectifiers. Diodes are used in rectifier circuits in order to convert AC to DC in various electronic devices. Clipping and clamping circuits. Diodes are used in clipping. Clipping is nothing but which we are going to cut some portion of the waveform. That is nothing but clipping of this waveform. So we can use these diodes in the clipping as well as in clamping circuits. Clamping is nothing but shifting the waveform from one position to another position, that is above 0 or below 0, we are going to shift. That is nothing but the clamping of the circuit. And this clipping and clamping, we are going to use the diodes in order to modify or limit the shape of input signals. And voltage regulation. Here whenever we want to go with the regulation of voltage, we are going to use the Zener diode, because Zener diode output is constant voltage. Even though you change the input, the output will be constant. That is the maintenance of, that is the major advantage of Zener diode. Zener diodes are used for voltage regulation in electronic circuits. And logic gates, the diodes play a crucial role in constructing logic gates, which form the building blocks of the digital circuits. These diodes are going to be used in the logic gate circuit, that is OR and operations, where these diodes are going to play a very crucial role in order to control the input and output signals. And signal demodulation, here diodes are used in demodulation circuits to extract the original signal from a modulated carrier wave in communication systems. Here in communication system, we also use these diodes in order to modulate the signal from the carrier wave. And the protective circuits, the diodes are used in protective circuits to prevent damage from the voltage spikes and reverse voltage. So these diodes are used in protective circuits to prevent damage from voltage spikes and reverse voltage. Here, wherever we are going with the protection of the equipment, there we should not allow the sudden changes in the voltages. So at that particular place, if we place the diodes, that will not allow sudden changes in the voltage, and it will not allow the reverse voltage also. And photovoltaic devices, and photodiodes, a type of semiconductor diode, and that are used in solar cells and light sensors for converting light energy into electrical energy. Here photodiodes are nothing but it is a type of semiconductor diode where this diode is going to convert the light energy or photon energy into the electrical energy. And temperature sensors, silicon diodes in particular can be used as temperature sensors due to their temperature dependent voltage drop. Here the diode is going to reduce the is going to have the tendency to, when the temperature increases or decreases, there will be a change in the voltage drop across the diode. Based on that, we can use the diodes as a temperature sensors. And high frequency applications, here the semiconductor diodes such as Schottky diodes are used in high frequency circuits including mixers and detectors. And RFID technology, here the diodes are used in radio frequency identification circuits for rectifying signals received from RFID tags. Here these diodes are going to use for rectifying the signals which are received from the radio frequency identification circuits. And crystal radio receivers, and these semiconductor diodes are also used in crystal radio receivers for detecting radio signals. And tunnel diodes in applications require high speed and negative resistance characteristics. The tunnel diodes will be useful. And varactor diodes, and these are used in wherever we require variable voltage capacitors in tuning circuits for radio and television receivers. And voltage multipliers. The diodes are used in voltage multiplier circuits in order to generate high DC voltages from AC sources. The next one is the advantages of transistors. Here, the first advantage of transistor is the amplification. Here, transistor is going to amplify the signals, that is nothing but which will take the minimum input and it will give the maximum output. That is nothing but strength of the signal is going to be increased, and that will be used in various applications. And miniaturization, the transistors are small, contributing to miniaturization of the electronic devices and circuits. And low power consumption, compared to vacuum tubes, transistors generally consume less power, making them more energy efficient. And the next one is high reliability. The transistors have a longer operational life and higher reliability compared to vacuum tubes. And low heat generation, that is, transistors generate less heat during the operation compared to the vacuum tubes, which will reduce the losses in the system and which will contributing to better thermal management in electronic devices. When there is a less heat, which the maintenance of the devices is less, so which will be useful for contributing the better thermal management in electronic devices. And fast switching speed, the transistors can switch on and switch off rapidly, enabling high speed digital operations in electronic circuits. And low cost, the transistors are cost effective to produce, contributing to the affordability of the electronic devices. These are very less cost, which will be helpful in contributing to the electronic devices. And compatibility with integrated circuits, the transistors are easily integrated into complex integrated circuits, which will facilitate the design of the sophisticated electronic systems, because the transistors are very smaller in size, so these can be adaptable for different complex circuits in the design of different electronic systems. And versatility, the transistors come in various types. One is bipolar junction transistors, field effect transistors. There are different types of different classifications of transistors with different characteristics, which will allowing for versatile applications in electronic circuits. And temperature stability, the transistors often exhibit stable performance over a range of temperatures, which will contribute to their reliability in different environmental conditions. The applications of transistors. The first major application of transistor is amplification. That is, transistor will act as a amplifier which will increase the input signal, or which will strengthen the input signal, whatever the signal which we are going to give. Transistors are widely used in amplifiers in audio and radio frequency and microwave circuits to increase the strength of signals. The next one is switching. The transistors are essential components in digital circuits serving as switches to control the flow of electrical signals. In the oscillation, the transistors are used in oscillator circuits to generate continuous waveforms, which is crucial for applications like signal generation in communication systems. In signal modulation, the transistors are employed in modulator circuits to modulate signals for various communication purposes, including amplitude modulation and frequency modulation. And voltage regulation, generally the transistors are used in voltage regulation circuits in order to maintain the output voltage as stable, ensures that the reliable operation of electronic devices, which will use the which will be helpful in regulating the voltage. And the logic gates, the transistors are the building blocks of logic gates in digital circuits, which will enable the creation of complex computational systems. In the audio amplification, the transistors are used in audio amplifiers for amplifying signals in audio systems, such as in amplifiers for musical instruments or audio playback devices. Here, transistor is a component which majorly used for amplification, that is nothing but increasing the signal. So that's why in all the audio instruments, wherever we are going to use the all the audio instruments, there we are going to use these amplifiers for musical instruments or audio playback devices. And power amplification, here high power transistors are employed in power amplifier circuits for applications like driving loudspeakers or power hungry electronic devices. And radio frequency amplification, the transistors are used in radio frequency amplifiers in order to boost the signals in communication systems operating at radio frequencies. And digital circuits, the transistors are going to be useful in digital circuits in the computers or in microprocessors, wherever we are going to have the small chips and integrated circuits, where we are going to have in all the digital circuits, these transistors will play a major important role. And voltage controlled oscillators, the transistors are used in voltage control oscillators to generate oscillations whose frequency can be controlled by an applied voltage. And this is used in frequency synthesizers and phase locked loops. And light emitting diode drivers, the transistors are used to drive LEDs by controlling the current flowing through them. And the next one is switched mode power supplies. Mainly in the power supplies, in order to go with the control regulating the voltage, we are going to use these transistors. The transistor play a crucial role in SMPS circuits, where they switch rapidly in order to regulate the output voltage efficiently. And temperature sensors, some transistors like bipolar junction transistors can be used as temperature sensors based on their temperature dependent characteristics. Here the BJTs are having temperature dependent characteristics. So because of that, whenever there is uh, any wherever there is a requirement of temperature sensors, in that particular case, we can use these transistors as a temperature sensor, which will be acting like a sensor, and which will gives the temperature as the output. And solar cells, transistors are used in charge controllers for solar cells, which will regulate the charging of the battery from solar panels. The next one, advantages of amplifiers. Signal amplification. The first advantage is the primary function of amplifier is to increase the strength or amplitude of the electrical signals, making them crucial for various applications where signal enhancement is needed. And improved signal to noise ratio. And amplifiers can boost the signal strength, helping to overcome noise and interference in communication systems and electronic devices, thereby improving the signal to noise ratio. And information transmission. The amplifiers facilitate the transmission of information over long distances by compensating for signal loss along the transmission lines. And signal conditioning. Amplifiers can shape or condition signals to match the requirements of downstream components or systems. And the next one is increased sensitivity. Amplifiers can enhance the sensitivity of sensors and detectors, making them more effective in detecting weak signals. The power gain. Power amplifiers will produce the power gain, which will enable the driving of high power devices such as speakers, antennas, or motors. In low noise operation, amplifiers are designed for low noise operations, are crucial in applications like communication systems and scientific instrumentation, where signal fidelity is essential, because when the noise is less, that is electronic devices what we are using, that is very helpful because there is no noise disturbance. The biomedical applications. In medical devices, amplifiers are used for amplifying weak bioelectric signals such as those from electrodes measuring brain activity, EEG, or heart activity, ECG. That is, whatever the low signal will be converted into high signal, that will be used in the biomedical applications. The instrumentation. Precision amplifiers are used in instrumentation applications where accurate signal amplification is crucial, such as in measuring instruments and sensors. And audio systems. Amplifiers are the fundamental components of audio systems, which will amplify the signals from sources like microphones or musical instruments to drive the speakers. And radio and communication systems. Amplifiers are used at various stages in radio and communication systems in order to boost signals for transmission and reception. And television broadcasting. Amplifiers are employed in television broadcasting to amplify the video and audio signals for transmission. And radar systems. Amplifiers are crucial in radar systems for amplifying weak return signals from distant targets. And wireless communication, amplifiers play a vital role in wireless communication systems where they boost signals for efficient transmission and reception. And optical communication, optical amplifiers are used in fiber optic communication systems to amplify optical signals without converting them to electrical signal. In photodetectors, in the optical communication and sensing, amplifiers are used to boost weak signals from photodetectors. And research and testing, amplifiers are used in laboratories and research environments to amplify and analyze signals in various scientific experiments. And guitar amplifiers, in the music industry, amplifiers are used to increase the volume of electric guitars and other musical instruments. And the microwave and radio frequency applications, amplifiers are employed in microwave and radio frequency applications, including satellite communication, radar, and wireless networking. And biotelemetry, in telemetry system for monitoring living organisms, amplifiers are used to enhance signals from implanted sensors. These are the some of the advantages and applications of semiconductor devices such as diodes, transistors, and amplifier circuits. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.